So we had discussed this problem in the previous class, and also I had given you 1100, isn't it? So have you all done it?
Yes, sir.
Okay, fine. So is there any doubts with those problems, this kind of sequence detectors? Any issues as to how it can be done? Now, these were implemented with respect to Mealy. Okay. So in your exam point of view, okay, it can be asked either in Murray or Mealy, any of the concepts. Now, what you all can do is take these problems, 1001 and the previous one, which is 1010. Okay, try to implement this in your Murray state machine. Okay, I have written only Mealy here. Now try to extend this and put it up in the form of Murray. So what is the difference that is going to happen in Murray state machine? Yes, can someone tell me? What changes do we have to do?
Output is within that state only, sir.
Yes, output is within the state, and we are having only inputs at the outside. Okay, so try to do that, and it is going to be as a practice for all of you. And then we will move on to the next concept. Okay. So I have put up this here. Okay, so that will be easy for you to start working on it. First one, second one, and the third one. Okay, start working on them. The only thing is the structure would change. Okay, so here you see, okay, this section you see. This section, I'll put it up here. Okay, so this will be S0 by 0. Okay, this is S0. Okay, then it will go to the next state. Only the input will be here 1. Understood? 0 is going inside. The next one is going to be S1, and whatever is the output will come here. Any doubts? Any doubts?
Sir, for the state S0, sir, why are we writing 0 inside, sir, and why 1 outside?
This is Murray, right? Fine. Forgot. S0 is the output, right? Output comes inside.
Oh, yes, sir. Yes, sir. Got it, sir.
No forgetting. That's why I tell you, keep in touch with your concepts. 1, 0 goes that side or this side. Okay. Here also, while copying the problem, instead of you writing 1010, if you just write 100 or 1100, then the whole thing is going to go wrong. Even here, instead of writing 1001, if you write 1010, the whole thing goes wrong. Right? Be very careful. Keep revising the concepts. That's why I do share my lecture videos as well. Okay, so that it becomes easier for you all to understand.
So, sir, when we are moving from state S1 to S2, on the arrow we will write 0.
Yes.
S1 to S2.
Yeah, the same thing. See, whatever graph is here, no, the same thing. Only the representation changes. Okay, only the representation changes. Instead of writing
Yes,
it
sir.
outside, you will be putting it inside. Very simple. Try to finish it. Okay. Students, any doubts you can ask me. Puneet M, have you understood?
Yes, sir.
Yeah. So any doubts, you ask me.
Okay, sir.
Oh, everyone. Any doubts, please ask. So after this, randomly, I'm going to check, okay, if you have done it or not, all of you. You'll have to turn on the video and explain as to how you have done it.
Excuse me, sir.
Yes.
Sir, could you just explain the melee machine, like the ones after we show the arrows from the states, like other than the inputs, like 0 bar 0? That could you just explain that once?
You had doubt with that?
Yes, sir.
Okay, fine. So probably once we are done with this, should I explain or you want me to explain it right away? Once we are done with this assignments, I mean this practice
Sir,
problems.
anything is fine, sir. I don't.
Okay, fine. So we will just wait for some time. Okay.
Okay, sir. Okay, sir.
Let your friends finish, and then we'll just give them about 5 to 10 minutes, and then I will again revisit this implementation of melee machine. Okay.
Yes, sir.
Yeah.
Yes, sir.
So have you all done it? Have you all solved these 3 problems which I've told? Yes.
Sir, just 2 minutes, sir.
Okay.
2 minutes.
Okay. Yes, all done with the problems?
Yes, sir.
Okay, fine. So can you show me as to what you have done? Lavanya, can you show me what you have worked out?
Sir, I haven't done the full thing. I asked you about the other part, so I didn't know how to do it in the moon machine.
Okay, so you have questions.
Done
Okay,
only the inputs. Yeah.
the inputs part. Okay, fine. Mamta? Mamta, you're there? You can unmute and respond. If you have completed, yes, you can show. Okay. Next, Musa Sheikh, can you show me what you have worked out? Anybody wants to show their workouts? Lokesh Biswas, would you like to show your workout?
Yes, sir.
Okay, yeah, good.
So is it visible?
Wait a minute. Just a moment.
The lower hand.
Yeah, now it is visible. Okay, can you tell me what you have worked out?
Sir, if the first one is 1010,
I think
the
all of
output
you are able
remains
to see, right? Students?
Yes, sir.
Yeah. Okay. Go ahead, Lokesh.
the output remains 0 for S0, S1, and S2.
Hmm.
Output is 1 for S3.
Okay.
If first first input is 1, it goes to S1. If it is 0, it stays in the same state. If next input is 0, it goes to next state. If it is 1, it stays in the same state. For
Okay.
S2, if the input is 1, it goes to next state. If it is 0, it goes back to initial state, S0. And for S3, if input is 0, output is 1, and if input is 1, it goes to S1.
Okay. Rohit, is it clear? Is it the same as yours?
Sir, the last state, I'm a bit confused, sir.
Okay, last
S4, what do I don't understand.
last state, can you explain, Lokesh?
So from which part, 0 or 1?
From where do you have doubt? Rohit.
Sir, S3.
Go ahead, Lokesh.
S3, we can directly go to S1 because initial state, if it was 1, it would go to S1. So we can directly go to S1 instead of restarting.
See, the only thing here, students, try to understand, the only thing here is whatever is outside, okay, that one you are actually bringing it inside, which is nothing but your output. Okay, your inputs will all remain the same. So once you have worked out one of the state machines, it's very easy to switch to another state machine because you already have the data with you. You know from what state to what state, you know what are the inputs, you know what are the outputs, and which state it is staying back, right? So all those things are clear. Only thing is you'll have to just make sure that the output is not mentioned. That's it. Output is mentioned inside. Is that clear?
Sir, I have a doubt, sir. Sir, in state S2, sir, we can bring it back to S2, same state, no, sir? Or it is compulsory that we have to go to S0 from S2?
If it
when
is
the
zero,
input is 0.
We want 1, no? We want 1,
so
right?
it is compulsory to go to S0, sir?
Because, see, because not will go ahead.
I thought because
one.
Since we are getting already 2 states are correct, no, sir? Because since already we are getting 2 states, no, sir, that is 1 and 0. So is it compulsory again to go to S0?
Yes,
sir?
you have to, because you need to check it for 1, right? You need that sequence. So I'm just connecting my circuit there.
Okay, sir.
I'm just connecting my circuit to S0, so that what is going to happen, ultimately I know, just like how I told you in the previous, if you want some chocolates, then you can go to a chocolate store. If you want the milk, you can go to the milk store. Okay. If you want some groceries, you can go to the grocery store, right? So you cannot go to the other store and ask for something else which they don't have, right? So this is going to happen only if it gets connected to S0. Is that clear? Now, for those of you who have doubts, okay, majority of you have followed it, okay, just for the benefit of those of you who have doubts with this pattern detector, okay, we will revisit the concept, right? Okay. So now our question is, to design a sequence detector which detects 1010. Okay, so initially I'm going to check as to how many states are here. Okay, how many bits are here. So corresponding to each bit is going to be a state, and each state, as I told you, okay, each state will have responses. Either it can have input as 0 or it can have input as 1. So accordingly, I will write what is my output if it is 0, okay, and if it is 1, what is my output. Now till here, have you understood? Yes, for those of you who have doubts, please respond.
Yes,
Till here, okay, fine.
yes, sir.
So we will start off now with the S0, okay, or see, it's not that you have to start with S0, you can even start with S1, but generally good to start with 0. So I will take S0 here, okay, and I will design my system in such a way that, okay, S0, S1, S2, S3, and it will move from one state to another state only if these bits are given as input. If it's not there as input, then it will again go back to a different state and seek for that value. Okay, so that's the concept here. So S0 will go to S1 if only the value is 1. And we have not found out the full sequence. If we have found out the full sequence, okay, if the full thing is found out 1 0 1 0, then only my output is going to turn 1. Until I get the full sequence, my output will always be 0. Keep this in mind. Okay, so it's moving now from S0 to S1, okay, when the input is 1. So we are done with this. Next, it moves from S1 to S0 if the input is 0. This is also done. I am writing it like this. Okay, first the initial part. We will finish off the initial part. Later we will think of the other cases. So if 0 is there, then I'm going to check for 1. If 1 is there, then I'm going to check for 0. Okay, fine. So 1 0 is done. Next it will move to another state from S1 to S2. Okay, so that will happen when we have got 0. Now from S2 it will move to S3 if it has the value 1. So which means this third bit is also done. Now in the last, okay, in our last state S3, it will actually complete the loop. Okay, it will complete the loop and it will go back to the initial state if and only if it receives 0. So this part is also done. Now check out the output part. The output part has become what? 1. Understood? This section has become 1. Why has it become 1? Because we have detected all the input bits. Till here, any doubt?
No, sir.
Yes, Lavanya, till here any doubt?
No, sir.
Fine. Now we are to look for different cases. That is, if I have taken 1, then I will search for 0. If I have taken 0, then I will search for 1. I will look for that case. Right? Okay. So now here I've taken 1. Now I have to think when it is 0. Always 99%, not 99, 100%. Okay, your first state will always be in the same loop. Okay, so because there is nothing else below and above. Okay, so when it's in the initial state, it should be in the same state if it's not getting 1, if it is 0. Here any doubt?
No, sir.
Okay, only if it's 1, then it is released and it goes to the next state. If it's not 1, it will be in the same state. If it is 0, it will be in the same state. It's not released to the next state. It is not promoted to the next state. Understanding? It is just like promotion. How will you get promotion? or how will you get promoted to your next semester? Only if you have satisfied your current semester requirements, right? Only if you clear all your subjects, or you have proper attendance, your performance is fine, then only you will move from state 0 to state 1, which is your third semester to fourth semester, or any semester for that matter, right? You will be moving to a higher semester. So that happens only if my input is 1. Why is it 1? Because I have decided that this is my stream of data. Okay, so when it is 0, it stays back in the same state. When it is 1, then only it migrates to the next state. Now let us take with the state S1. So when it is 0, it's moving. So when it is 1, I have to think what is to be done. So when it is 1, okay, what I will do is, since here I have already got a 1, okay, I do not want another 1. I want a 0 here. Okay, so 0 I will get only from this state. So I will loop it back to the same state. Understood? Yes? Yes or no?
Yes, sir.
Fine. So now let us go with the next state. Next state. Lavanya, any doubt? Are you there?
Yes, sir. Yes,
Huh?
I'm here.
Yeah,
No
fine.
doubt, sir.
So now let us go to the next state. So S1 is migrating to S2, okay, only if the value is 0. If it's 1, then it will stay back in the same state. Why in the same state? Because I'm interested only to get a 0. Here I cannot get a 0. Here I'm getting only 1, right? Only for 1 this migration is happening, but I want something where if 0 is there, so I'm getting 0 only with S1. So it will stay back in the same loop. Now let us go with the next case. Okay, in S2 is going to S3 only if I have a 1. If it is 0, okay, if it is 0, then what is going to happen? Now I am interested in getting a 1. This was your doubt, right? Someone, Krishnan, or someone asked me this doubt, isn't it? Rohit, or was it Rohit who asked me this doubt?
Yes, sir. Yes, sir.
Yeah, you can even connect it here, okay, which actually responds to 1, or you can even connect this here. I think I had mentioned this in my previous class. Yes or no? Because why can I connect it here? Because I've already got a 1, isn't it? Yes or no? I am looking for only
Yes,
those
sir.
values. Yeah, I'm looking for only those values. Here also you're getting 1. So I can connect this even here, no problem. Okay. The reason why I'm connecting here is I might hoping that, because I already have 1 0. So 1 0. So I might get that sequence. So I'm just hoping that and connecting it here. But we can even connect it back to S2. That's also fine. Lavan, any doubt here till this concept?
No, sir.
Fine. So we got 1, and then next we are interested in getting a 0. But here, if in case after this 1, if I get a 1 more 1, but I'm interested in getting a 0. So what I will do, I will connect it to state S1, because that's the only state which is actually giving me what? State 0. Can you tell me the other option? There is another possibility for this.
So we can connect it back to S3
Yes,
itself.
to the same state only we can connect. That's also the other possibility. Okay. So in this way, I am making sure that I am getting only 1 0 1 0. Hook or crook, I should get only this value. Okay, so I'm designing my system in such a way that I'm not allowing it to deviate. You're getting a 1? No, I do not want you to get 1. Go back to the same state. You're getting a 0? No, I do not want a 0. Go back to the same state. I'm interested in 1. Okay. So trying to get it on track. So I hope you have understood this concept. Yes?
Yes, sir.
Fine then. Okay. So the same thing can be represented in your other form, wherein your outputs come here, okay, inside the state circle, okay, and the inputs will stay outside. Okay. So you can just see that here in one of the examples I have explained how the representations are in the introductory classes I have mentioned. Right? Yeah. So this is going to be your general representation for your Murray model. Okay. Your output is actually going to stay inside. Okay. And your input is going to stay outside. Right? And here also no need to write the output. We used to write 0 by 0. Here also no need to write. Only here we will be writing inside the state. Right? So either of the model, if you have done, it's very easy to migrate to the other model. Okay. Fine. Any doubts till this concept that we have discussed, students? Is it all clear?
Yes, sir.
Fine then. Okay. So we will try catching up in the next class, and we will try and design a counter. Okay. So we'll be discussing about how to design a counter, and of course, it's going to be pretty interesting as to how we can analyze things. Okay. So we'll be solving this problem in our upcoming classes. Okay. Fine. Thank you all.